class, this is Professor Smith. I'm so excited to do a new video on central limit theorem sample proportion. In this example, we have 12% of the world's population is left-handed. So since they tell us it's 12% and it's of the world's population, that percentage or proportion is going to be our population proportion P. So P is equal to 12%. A researcher claims that the left-handed individuals are more creative than those who aren't left-handed. In order to support her claim, she takes a sample of 1,650 artists and finds that 10% of them are left-handed. So what's the chance that that happens? So let's answer the following questions. The first question asks to find the mean of the p-hats. That's the sample proportions of size 1650. What's the mean of those? Well, it turns out the mean of the p-hats is always equal to the population proportion, that 12%. So the population proportion is 12%, which we can write as 0.12. That will always give you the mean of the p-hats. To find the standard deviation for the p-hats, we use the following formula. To find the standard deviation of the p-hats, we're going to use the following formula. It's equal to the square root of p, which is 0.12, our answer in A, times 1 minus p, so 1 minus 0.12, or we could put in 0.88, all divided by the sample size, divided by 1,650. Make sure when you're taking that square root that you are indeed making sure that that 1650 is in the radicand. It's in the denominator and not underneath the radical. Sometimes students make this mistake and they write divided by 1650. And so that's the error you don't want to make. Make sure that 1650, that sample size, is part of the radicand. That means it's trapped underneath the radical. The way you do that, if you hit the division bar on your keyboard right after the parentheses, it will automatically place it underneath the radical. So let's go ahead and find the standard deviation. Again, the formula, P, 1 minus P, all over the sample size. So we get 0.008, and ALEKS is nice. If you get some funky answer like 0.073499278, that means you probably made a mistake. The next thing they ask us to find in part C is to compute an approximation for the probability of the sample proportions that are less than or equal to 0.10, that 10%. What's the chance that that would happen? So let's go ahead and find that. The first thing we need to do is find the z-score. So you say, well, how do I find the z-score? Well, to find the z-score, you take the value of 0.1, which they give us in the problem, that's the sample proportion, minus the population proportion, that's our answer from part A, divided by the standard deviation of the p-hats, and that's going to be our answer for part B. So again, let's say that again. You're going to take what they're asking you to find, the probability that p-hat is less than or equal to 0.1. That value is always going to be the first part in finding the z-score. The next value is going to be the population proportion, which is equal to the mean of the p-hats, so population proportion, divided by the standard deviation. So basically, it's going to be the value that you have here, 0.1, minus the answer in A, divided by the answer in B. That's going to help us find our z-score. So let's do that. So we get a z-score of negative 2.5. And to find the probability that p-hat is less than or equal to 0.1 is equivalent to finding the probability that z is less than negative 2.5. We hit equals, and we get 0.006. They ask us to round our answer to 4 decimal places. So since the 5th place is a 0, our answer is 0.0062. Let's check. And we're correct. This means that's a 0.6% chance that 10% of the artists would be left-handed. I hope this movie on central limit theorem sample proportion was helpful for you.